In the fragmentary histories from the Bible to the scripts of Babylon,
Let's look at a story from the vault that throws light on the origin of mathematical astronomy in ancient Mesopotamia.
Writing allowed us to save our thoughts and send them much further in space and time. Tiny markings on a clay tablet became a means for us to vanquish mortality. It shook the world.
During the time of this tablet, the scribes collected countless observations of the moon and planets, searching them for omens that might correlate with agricultural prices, civic health, and affairs of state.
Ever since the first people were gazing up at the sky, they had to have noticed Venus. It's so incredibly bright. In ancient records of the Mayans, the Greeks, the Chinese, people all over the world were seeing Venus up there, naming it and writing all sorts of stories about it.
This dragon here, called a mushkhushu, is about 2,500 years old, and it comes from Nebuchadnezzar's capital city, Babylon, in the middle of ancient Iraq. And when you see it now, when you look at it and look in its eye, it might strike you as something very alien and very distant and nothing to do with the modern world. Well, the culture from which it comes, the Babylonian world, is surprisingly close to ours. And the thinkers and the writers and the poets and the mathematicians of that ancient culture came up with things which still exist today in our modern lives and are part of our daily life all around us. These Babylonian discoveries and ideas are conveyed to us through the ancient form of writing called cuneiform, written on tablets of clay or stone. The Babylonian language is fully understood today, so that many of their ideas and achievements have been preserved for us. Great engineers have come up with very ingenious machinery to measure the passage of time. And one of the interesting things about the ancient Babylonians was that they had a mathematical system based on 60, not on 10 like we do today. And one consequence of this is the fact that our own time division of the minute and the hour into 60th parts is a direct inheritance of a principle which goes back to ancient Babylon. And it's come down to us somehow through the Greeks, who looked at Babylonian ideas, incorporated them into their own work, and maintained this 60 figure as a central calculating device. And that is why everyone who has a watch on their wrist or a clock on their kitchen wall is somehow perpetuating the work of these ancient Babylonian thinkers. The Babylonians were always attempting to predict the future. This clay model of a sheep's liver, complete with gallbladder, was used to teach the art of divination, the zones and cuneiform inscriptions revealing the ominous signs. Much later, people relied on dreams or the stars for their portentous messages. Another thing that's come to us from ancient Babylon are the signs of the zodiac. And this goes back a long way. Already in the second millennium, some of the figures which became the zodiac figures were already to be found on monuments. And side by side with the zodiac grew up in the late period the idea of the horoscope. So the thing when you open your newspaper and you look up your star sign and read what it predicts, or you get a horoscope, those two ideas likewise come from ancient Babylon.
To the naked eye, 5 stars sometimes appear brighter than the rest, and watched over the course of nights, they seem to move against the backdrop of the other stars. Each of these bright stars is a planet, a name that simply means wanderer in Greek. Venus, the evening star, skims the horizon at sunset. Mars glows red. Jupiter and Saturn outshine everything around them. We now know that these wandering stars are actually other worlds, like the Earth, planets as we understand them today. But in Galileo,
For the next 300 years, Venus continued to be an obvious target for telescopes. These early observations eventually revealed that Venus had a thick, dense atmosphere. This discovery would define our image of the planet. Rather than seeing it as a meandering bright star, Venus was now our mysterious sister planet.
Early in the 20th century, we were making huge advances in science in all kinds of different fields. With advances, we started getting observations of Venus using spectroscopy and using ultraviolet wavelengths. The astronomers of the time were making fairly reasonable assumptions that the atmosphere on Venus is very similar to the one on Earth, and that the clouds that they were observing were made up of water vapor. And subsequently they concluded that the Venetian atmosphere was really wet and stormy and the surface was swampy. And a lot of astronomers at the time even concluded that it was really good conditions for life.
There's never been anything like this before, in fact or fiction. First spaceship on Venus.
Long before his weapon hit London, Wernher von Braun had aimed for the moon.
Von Braun was raised in an elite family, but he got interested in spaceflight very early.
As a small boy, he said, "I want to spin the wheel of progress."
Well, he joined an amateur rocket club launching what we would now think of as backyard toys. I have no doubt was probably perceived as a little weird at the time.
And this group of men shooting for the stars caught the attention of famous science fiction film director Fritz Lang.
Movie men like Fritz Lang were interested in the show business angle of launching these toy rockets.
But von Braun was soon offered a new starring role. The German army hired the young scientist for their rocket department.
They were interested in all sorts of advanced technologies, and they also noticed the small group around Wernher von Braun, which was developing rockets.
The Versailles Peace Treaty had forbidden weapons like tanks, planes, heavy artillery to Germany. But nobody had thought of mentioning missiles.
Von Braun quickly emerged as a brilliant young man who, even in his early 20s, was capable of leading a huge group.
The German army put von Braun to work to develop what was to become the world's first ballistic missile, an unmanned projectile some would argue by today's standards would be a weapon of mass destruction.
In 1945 the Soviets had captured several V-2 rocket production facilities and also some of the German scientists working on the project. In October 1946, the Soviets transferred the German missile engineers working for them to a special research facility near Moscow. The Soviets established a missile design bureau of their own, known as OKB-1, under the direction of Korolev. This team was directed to create a Soviet capability to build missiles, starting with a Soviet copy of the V-2. In April 1947, Stalin authorized the production of the R-1 missile. The first test of this missile began in September 1948.
Venera 1 was launched on February 12, 1961, 34 minutes after midnight UTC from Baikonur Cosmodrome's Site Number 1. Venera means Venus, and as the name indicates, the probe's mission was to fly by Venus and relay scientific data on our close neighbor. It had a mass of 643.5 kilograms and was launched on a Monia 8K78 rocket, a variant of the R7 with both an upper stage as well as a Block L transfer stage.
The date, the 18th of October, 1967. On this day, Venera 4 became the first probe to successfully transmit data from another planet. Venera 3 was originally meant to land on Venus in 1966 and send back data to the USSR about Venus's atmosphere and environment. The mission failed, however, and the probe is probably the first man-made object to impact on a planet other than Earth. Venera 4 was launched on the 12th of June, 1967. As with its predecessor, it was intended to take atmospheric readings and to land on Venus. At a planned course correction on the 29th of July, at around 12 million kilometers from Earth, Venera 4 entered the Venusian atmosphere on the 18th of October, enduring temperatures of 11,000 degrees, the maximum its heat shield was designed to be exposed to. The scientific instruments were turned on 5 minutes after reaching an altitude of about 55 kilometers, and remained on for 93 minutes, until the probe reached an altitude of roughly 25 kilometers, where it succumbed to the atmospheric pressure. Although Venera 4's design did allow for data transmission after landing, the Venera 3 to 6 probes were not built to withstand the intense pressures at the Venusian surface. The successful transmission of data and relatively long survival time of the probe made the mission an encouraging prelude to the first successful landing and subsequent data transmission on Venus, which was achieved by Venera 7 in 1970. The first probe in communication with Earth and intact to land on another planet.
3, 2, 1, 0. All engine running.
There are many mysteries yet remaining about the planet Venus. These mysteries will be solved by further analysis of our present data, and hopefully by more experiments of this type in the future.
NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report.
According to all trajectory calculations.
NASA's Mariner spacecraft, after traveling 4 months and 217 million miles, began fulfilling its mission as it rendezvoused with the planet Venus.
By 1967, we actually had 2 successful missions make it to Venus. The first one was the Soviet Venera 4, and nearly a month later it was followed up by the NASA's Mariner 5. The interesting thing about that we were in the middle of the Cold War, and despite that, the Soviet and American scientists were working together, cooperated, shared the data, and the picture that the scientists got of Venus was much more inhospitable than they really imagined. By 1967, if there were any doubts about whether Venus was livable or not, those doubts were washed away.
Now in an unexplored region of space, Mariner was placed on its Mercury intercept course by the gravity of Venus, the initial target on this first dual-planet mission. Mariner 10 took more than 3,500 pictures during its rendezvous with Venus in February.
For the first time, after a decade of exploration, Mariner 10 was carrying cameras. We had ultraviolet cameras. We could actually make some of the most beautiful images. I mean, here we have Venus, the goddess of love and beauty, and we had yet to really make a close-up picture of her. Pioneer Venus was the last NASA mission to go to Venus to study specifically its atmosphere in detail and the dynamics of that atmosphere. That was 30 years ago that we sent it there. It took a lot of detailed data that allowed us to test the theories that we had about why Venus was such a strange environment. And one of the most interesting, of course, is this idea of the runaway greenhouse effect as an explanation for why is Venus so super hot.
So while the Pioneer Venus orbiter was sending a steady stream of data back to Earth, the Soviet program undertook several more, actually 8 missions back to Venus. And the highlight of this set of missions was Venera 13 and 14, which made it to the surface of Venus, and while they were active there for 45 minutes, they took a handful of color panoramas of the Venetian surface. Now that they have been reprocessed, they present a stunning view of the Venus surface. And forgetting the heat, toxic atmosphere, and the pressure, it really looks tranquil.
It's an eerie, desolate-looking planet. A surface like no other world we've explored, yet with features like those of Earth. Alien-looking, with spidery-shaped lava flows and unusual volcanoes. Scars of impact craters. Rugged mountains crumpled the edges of broad, windswept volcanic plains. Ancient beds of lava rivers meander across a forbidding terrain. This is not a likely world for human exploration, yet we have studied it for years. In fact, we've sent more spacecraft to study this planet than any other, to orbit and map its surface, to pierce the clouds and land, and radio back the data to scientists on Earth. This delicate-looking spacecraft was given the dignified name of 16th century explorer Ferdinand Magellan. Like its namesake, it too explored a wild and unknown world, the world next door.
Venus is Earth's closest neighbour. Just over 43 million kilometres away, it's always been an object of fascination for astronomers who believed it to be similar to Earth. In 2005, ESA launched the mission Venus Express, and after 8 years of intensive observation, we now know a lot more about this mysterious planet.
In the early days of the solar system, Venus and Earth must have been very similar. But then something happened, and they took a different route in its evolution. But Venus has developed in a completely different way. The temperature down on the surface is more than 450 degrees Celsius, and the surface pressure is 92 bars. It's almost 100 times more than the Earth. You have clouds that are made up of sulfuric acid, in fact. So it's a very nasty place to be at. And that's one of the big questions on Venus. Why did Venus go that way, and why did we on the Earth go this way?
On Venus, days last longer than years, with the planet taking 243 days to rotate on its own axis and only 220 days to go around the Sun. And it moves in opposite rotation to the Earth, with the Sun rising in the west and setting in the east. Venus also has other interesting characteristics. Not only is the planet subject to strange violent winds that travel at up to 400 kilometers an hour in its upper atmosphere, but it also has massive hurricanes over 200 kilometers across, permanently moving around the poles. All this information and large quantities of raw data about the planet have been generated by Venus Express during its time in orbit. This has been distributed to the widest possible audience, from experts to the general public. But why is it important to study Venus?
Mostly for fundamental science reasons, to learn about not just Venus, but about the solar system, how it evolved, why is Venus different from other planets like Mars and larger planets.
As Venus Express nears the end of its mission, scientists are making the most of the spacecraft's remaining lifespan by using it to make close-up observations of the planet. These maneuvers, called aerobraking, involve taking daring plunges into the planet's hostile atmosphere only 130 kilometers above the planet's surface. Though apparently risky, the information gathered during these are giving us even greater insight into our neighboring planet.
We are going so close that we actually sense the atmosphere as a friction against the structure of the spacecraft, and in that way we can measure densities in the atmosphere of Venus that we have not been able to measure for all those 8 years we've been circling the planet. We also measure magnetic fields with a magnetometer, and we measure energetic particles that we find there. So it's a very new type of measurements and very valuable data we're collecting these days.
So to the last, Venus Express is going beyond its original remit and providing us with yet more valuable information. This information not only helps us to understand the evolution of our solar system, but as the planet that most closely resembled Earth in its early years, being of the same size and formed at the same time, understanding Venus helps us to understand more about the potential future of our home planet.
Venus doesn't have a magnetic field. So Venus is just this big rock with this atmosphere and the ionosphere sitting in space, and the supersonic solar wind with the interplanetary magnetic field whacks into Venus, and it can't penetrate through the ionosphere. So the interplanetary field lines just sort of pile up ahead of Venus, like cars on a freeway. This solar wind whacking into it essentially sort of strips off the atmosphere, and it literally forms this long tail, like a comet, but stretching out into space. Pioneer Venus Orbiter was the first spacecraft to really thoroughly explore that night side region where the atmosphere is all escaping away, and it discovered this really mysterious phenomena which has yet to really be explained. Imagine that we're flying from pole to pole on the night side, so we're feeling the plasma around us, and then suddenly the ionosphere disappears, and then it sort of comes back. And this is what an ionospheric hole is. It's like a chasm in the sky, a big hole where the ionosphere is just absent. So Pioneer Venus Orbiter basically measured inside these things, and we saw that there is very little plasma, and there's all this magnetic field. And from that, they sort of suggested that this is essentially a magnetic structure that's sitting in the night side. I wanted to see if I could go looking for these things with Venus Express. What we saw is essentially this really exciting, strong, straight magnetic field lines that we expected, and really boring plasma signatures. It shows us that this is a magnetic structure, right? This is a tube of interplanetary magnetic field that, well, PVO saw it coming out of the ground, and now we've seen it way out in the tail. So these things really continue out to much higher altitudes than we previously have found them at. And the other thing that's important is, well, Pioneer Venus Orbiter only saw them during solar maximum, when the sun was really disturbed and really blowy and stormy. But we've now been seeing them all throughout the solar cycle. There's sort of two explanations for what might be causing this. One possibility is that these field lines, they come in from space and they get sort of stuck in the ionosphere. The ionosphere sort of flows from the day side to the night side, and as it goes around, it sort of meets this plasma that's in the tail, and there's sort of a pile-up between the two. So that's one idea. And the other idea is that on the day side, the field lines come in and they actually sink through the ionosphere, go through the rocky mantle, and then get hung up on this big metallic core. These field lines essentially end up draping around the core and stick out the rock at the back. One of the main differences between Venus and the Earth is simply that Venus doesn't have a magnetic field. So the way it interacts with the star is completely different. If you want to understand how did Venus get that way, why does Venus not have any ocean, you need to understand the interaction between the star and the planet.
There's an important zone on Venus which is actually surprisingly Earth-like, and that is the clouds, the high clouds, which are occurring at temperatures and pressures that are not that different from Earth's surface.
In the clouds of Venus, there are constant rains of sulfuric acid, which would be deadly to most known forms of life, but not all.
We do know life on Earth exists in very inhospitable places. So, for example, in caves, you get some bacteria, these extremophile bacteria, that can exist in a very acidic environment, somewhat like being in your car battery.
If life can thrive in acid environments on Earth, it can exist within the acid clouds of Venus.
Who knows what could exist in the clouds of Venus? It would be a whole ecosystem structured from bottom to top, from the simplest to the most complex. You could have predators flying through. You could have huge colonial creatures living above in the clouds, moving like beautiful balloons floating over the surface of Venus. Who knows, because nature always amazes us when it comes to life.
Today, scientists are investigating if Venus could support another form of life, humankind.
If humans are going to survive indefinitely into the future, we're going to have to leave Earth. We see in the fossil record that from time to time, much of Earth's life gets wiped out. And the more planets we have, the better.
Surviving in the Venusian clouds might not be as far-fetched as it sounds.
The source of oxygen is already there. It's just a matter of extracting it from the carbon dioxide. Water's there, nitrogen's there. You don't really need to import any basic life support material. It's all there. You just need to process it.
The technology to turn these ideas into realities is already in development.
Inflatable modules are already being considered for the International Space Station, so it's not such a big step to imagine that that kind of technology could be used to make a habitat that could float in the atmosphere of Venus.
Could Earth's twisted sister become our next home?
Finding signs of life on other planets beyond the Earth would be a way of answering the biggest questions that we've had as a species so far. Where do we come from? Are we alone? But of course, these questions are not the exclusive purview of scientists. People have been asking them for as long as there's any record of them being able to ask these questions. What is special about this moment and our role in it as scientists is that for the first time, we're actually able, because we have the tools, to answer these questions.
So a group of scientists led by Jane Greaves from the University of Cardiff were looking for signs, for chemical signs on Venus that shouldn't belong there. And one of such molecules is phosphine. And they, unexpectedly, they actually were able to find a signal that belongs to this molecule. So then we raced to figure out what could be the reason for phosphine on Venus. And this is where our MIT team comes, when we actually looked at all kinds of processes, chemical and physical, that could potentially produce phosphine in Venusian environment. This is an atmosphere. The surface of the planet is completely uninhabitable. The atmosphere is the only place in which life actually could, in principle, exist. And there is a belt of clouds in the atmosphere. And we concluded that there is no known chemical and physical process that could conceivably produce phosphine. So this adds to the mystery of Venus. And then this opens a very rather bold possibility that there might be something living in the clouds of Venus.
Phosphine is my favorite molecule. It looks more or less like this, a phosphorus atom on top and 3 hydrogens in the base of this pyramid. And phosphine is an extremely difficult molecule to make. It is only spontaneously made in extreme environments, such as what you find in the hellish depths of Jupiter and Saturn. It is otherwise only made either naturally by life on Earth or artificially by humans, as a fumigant, for example.
So the question is why it is actually a staggering discovery, why it is so important. Well, there are a couple of angles that you can actually answer that question with. One, the first, is that phosphine is absolutely unexpected and cannot be produced on rocky planets. At least we don't know of any known processes, chemical or physical, that can produce phosphine, which means either our understanding of the physics and chemistry of the rocky planet is severely incomplete, or there is some chemistry that is so unbelievably weird that it could even be life.
If we have indeed found life outside the Earth, it puts our own existence into perspective. But it also tells us that life may be much more common than we first imagined. And there's a huge array of possibilities out there in the galaxy of life with different biochemistries and desires. And of course, if we have found life right next door in our planetary neighbor, that would be so cool.
On the hottest planet in the solar system, a probe descends through a thick, poisonous atmosphere. It is both a time capsule and time machine, unlocking secrets of the ancient past, while revealing how a world can turn from possibly habitable to horrible. The location? Venus. Our sister planet has much to tell us about our own and exoplanets, helping ignite a scientific renaissance for our universe. The mission, brought to you by NASA Goddard and its partners, is aptly named Da Vinci Plus, the first U.S. probe mission to Venus in over 40 years. With the probe acting as chemistry lab and photographer, other cameras will map and gather additional views of the planet from above, providing a new study of Venus that has scientific implications well beyond our own solar system. Da Vinci Plus will give us a new understanding of planetary evolution. Launching in 2029, 3 years will be spent exploring our celestial neighbor. Da Vinci Plus, coming soon to a planet near you.
Epsilon 46, can you run a diagnostic on your movement systems? Copy that. Running diagnostics now. Sending data. There doesn't seem to be any system failings.